Alright, let's look at the homework 8.2, problem number 10. Let's find the surface area of the Gabriel's horn. Alright, so we just have to set up the integral. So our surface area S is going to be 2 pi integral from 1, and this is going to keep on going to infinity. Right, and the radius is just the function value, so it's going to be 1 over x, right? Because maybe I should draw a picture. So we're talking about, a band looks like this, circular, right? Then you can see that the radius is just the function value, right? Then we can just do the width is going to be just the arc length, which is right here, right? So it's going to be 1 plus, right? Then derivative y, so this is x to the negative 1, right? So if you take the derivative, so dy over dx, it's going to be, put the negative 1 in front, x, and subtract 1 from the power. Right? This is going to be negative 1 over x squared. Right? If you square that, you get 1 over x to the 4th. Right, with respect to x. Right, then what you have here is this. Let's compare. I'm going to put, let's say, 2 pi. So 2 pi over x square root of 1 plus 1 over x to the 4th power. And let's compare this with 2 pi over x. Right, so I'm just dropping this positive term. Right, if you drop the positive term, the quantity gets smaller. So we know that this is a smaller quantity here. Right, so let's think about let's evaluate this integral, improper integral, from 1 to infinity. Right, you have 2 pi. Right, then you have 1 over x dx. Right. This is going to be, right, there's 2 pi, right, so since there's an infinity, so we have to put, replace with t, and we have a limit as t approaches infinity, right, then you have a 1 over x dx, right, then you have a 2 pi, we still have a limit as t approaches infinity. Antiderivative 1 over x is a natural log of absolute value of x. Then you're going from 1 to t. Alright, so plug those in. So 2 pi, we still have to take the limit as t approaches infinity. And if you plug in natural log of absolute value of t minus natural log of absolute value of 1. Right? And this is actually natural log of 1 is 0. Right, however, as t approaches infinity, natural log of infinity is infinity, so this guy approaches infinity. And infinity times 2 pi is still infinity, so you're going to get positive infinity, right? Which means that this improper integral diverges, right? By comparison theorem, if the smaller guy diverges, then the bigger guy, of course, diverges too. So this guy actually goes to positive infinity. Right? So answer is, this is going to be infinity. So actually, I can't spell it out. Let's see. So symbols, infinity. Right? Let's check the submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. And make sure that this is by comparison theorem. Alright, that's it. I hope that this was clear.